When it comes to solar cars, the most critical component is undoubtedly the solar panels. These panels are the key to harnessing the power of the sun and converting it into electrical energy that can power the car's motor. Solar panels are made up of photovoltaic cells, which are responsible for absorbing sunlight and generating a flow of electrons. These cells are made of silicon, a semi-conducting material that is capable of converting sunlight into electrical energy. When sunlight strikes a photovoltaic cell, it creates an electric field across the layers of silicon. This electric field acts like a force field, pushing the electrons through the cell and generating a flow of electrical energy. This electrical energy is then sent to the battery, where it is stored until it is needed to power the car's motor. Solar panels come in many shapes and sizes, and the type of panel used in a solar car will depend on the specific design of the car. In some cases, the solar panels are integrated into the car's body, while in other cases, they are attached to the roof of the car. One of the most significant advantages of solar panels is that they can produce electricity without any moving parts or fuel consumption. This means that they are incredibly reliable and require very little maintenance. Additionally, solar panels produce no emissions or pollutants, making them an incredibly environmentally friendly source of energy. Overall, the solar panels are the heart of a solar car, responsible for converting the sun's energy into electrical energy that powers the car's motor. They are incredibly reliable, low maintenance, and environmentally friendly, making them an excellent option for sustainable transportation. As research and development in solar technology continues, it is likely that solar panels will play an increasingly important role in the future of transportation. Another critical component of a solar car is the battery, which plays a vital role in storing and supplying the electrical energy needed to power the car's motor. The battery is the primary source of power for the electric motor that drives the car. When the solar panels generate electrical energy, it is sent to the battery for storage until it is needed to power the car's motor. The type of battery used in a solar car is usually a rechargeable lithium-ion battery. These batteries are known for their high energy density, which means they can store a lot of energy in a small space. This is essential for solar cars because they need to be lightweight and efficient to maximize their solar energy input. The battery also plays a critical role in ensuring that the solar car is reliable and consistent. When the car is not receiving sufficient sunlight to power the motor, the battery can kick in and provide the necessary power to keep the car moving. Battery technology is rapidly improving, and the development of more efficient and longer-lasting batteries is critical to the future of solar cars. As battery technology continues to improve, solar cars will become more practical and accessible to a wider range of people. One of the significant advantages of using a battery in conjunction with solar panels is that it can store excess energy generated by the solar panels for later use. This means that even when the sun is not shining, the car can still be powered by the stored energy in the battery. Overall, the battery is a crucial component of a solar car, responsible for storing and supplying the electrical energy needed to power the car's motor. Lithium-ion batteries are the most common type of battery used in solar cars due to their high energy density and lightweight construction. As battery technology continues to improve, solar cars will become more practical and accessible, paving the way for a sustainable future of transportation. The electric motor is another key component of a solar car, responsible for turning the wheels of the car and providing the necessary power for the car to move. The electric motor is powered by the energy stored in the battery, which is generated by the solar panels. One of the main advantages of the electric motor is that it produces zero emissions, making it an environmentally friendly option for transportation. Unlike traditional gasoline-powered cars that emit harmful pollutants into the atmosphere, electric motors produce no emissions, which helps to reduce the carbon footprint of the vehicle. The electric motor is incredibly efficient, converting a high percentage of the stored electrical energy into motion. This efficiency is critical for solar cars, which need to maximize their energy input to ensure that they can operate for long periods without needing to be recharged. Another advantage of the electric motor is that it is very quiet, producing minimal noise pollution. This is because the electric motor has far fewer moving parts than traditional gasoline-powered engines, which reduces the amount of noise generated during operation. Electric motors come in various sizes and power ratings, and the specific motor used in a solar car will depend on the design and intended use of the vehicle. In general, however, electric motors used in solar cars are small and lightweight to maximize their efficiency and minimize their power consumption. Overall, the electric motor is a crucial component of a solar car, responsible for turning the wheels of the car and providing the necessary power for the vehicle to move. Electric motors produce zero emissions, are incredibly efficient, and produce very little noise pollution, making them an excellent option for sustainable transportation. As battery technology continues to improve, electric motors will become even more efficient and practical, paving the way for a future of cleaner and greener transportation. Power electronics are a crucial component of a solar car, responsible for controlling the flow of electricity between the solar panels, battery, and electric motor. They ensure that the car runs smoothly and efficiently, helping to maximize the amount of energy that can be harvested from the sun and stored in the battery. Power electronics typically consist of various electronic components such as diodes, transistors, capacitors, and inductors, which work together to control the flow of electricity within the car's electrical system. These components are carefully designed and selected to ensure that they can handle the high voltages and currents required by the system. One of the primary functions of power electronics is to convert the direct current, DC, generated by the solar panels into the alternating current, AC, needed to power the electric motor. This conversion is achieved using an inverter, which is a critical component of the power electronics system. Another essential function of power electronics is to ensure that the battery is charged and discharged efficiently. This is achieved using a battery management system, BMS, which monitors the battery's state of charge, temperature, and other parameters to ensure that it is operating safely and efficiently. The BMS also controls the charging and discharging process, ensuring that the battery is not overcharged or discharged too quickly, which can damage the battery and reduce its lifespan. Power electronics also play a critical role in ensuring that the solar car is reliable and safe to operate. They include various safety features, such as overvoltage and overcurrent protection, which help to prevent damage to the car's electrical system and ensure that the car is safe to drive. In summary, power electronics are a vital component of a solar car, responsible for controlling the flow of electricity between the solar panels, battery, and electric motor. They ensure that the car runs smoothly and efficiently, helping to maximize the amount of energy that can be harvested from the sun and stored in the battery. Power electronics include various electronic components such as inverters, battery management systems, and safety features, all of which work together to ensure that the solar car is reliable, efficient, and safe to operate. The regenerative braking system is another critical component of a solar car, responsible for recovering energy that would otherwise be lost during braking. It is a system that helps to convert the kinetic energy of the car into electrical energy, which is then stored in the battery, ready to be used to power the car when needed. Regenerative braking is a process by which the energy that is normally lost during braking is captured and reused. When a driver applies the brakes, the system uses the electric motor to slow down the car, just like in a traditional car. However, instead of dissipating the kinetic energy as heat, the system converts it into electrical energy and stores it in the battery. The regenerative braking system is incredibly efficient, capable of capturing up to 70% of the energy that would otherwise be lost during braking. This energy can then be used to power the car, reducing the amount of energy needed from the solar panels and extending the car's range. The regenerative braking system is typically controlled by the power electronics system, which monitors the car's speed and applies the appropriate amount of braking force to maximize the amount of energy that can be captured. The system is also designed to be seamless and transparent to the driver, so they will not notice any difference in the car's braking performance. One of the significant advantages of regenerative braking is that it helps to reduce the wear and tear on the car's brake pads and rotors. Since the electric motor is used to slow down the car, the brakes are not subjected to the same amount of stress as in traditional cars, leading to less frequent maintenance and replacement. Overall, The regenerative braking system is an essential component of a solar car, responsible for capturing and reusing energy that would otherwise be lost during braking. It is an incredibly efficient system that can help to extend the car's range and reduce its energy consumption. As technology continues to improve, regenerative braking systems will become even more efficient, paving the way for a future of cleaner and greener transportation. The body and chassis of a solar car are critical components that play a significant role in the car's performance and efficiency. In most cases, solar cars are designed to be as lightweight as possible, and this is achieved through the use of advanced materials such as carbon fiber. Carbon fiber is a composite material that is incredibly strong, lightweight, and resistant to corrosion. It is widely used in the aerospace industry and high-performance sports cars because of its unique properties. When used in the construction of solar cars, it helps to reduce the car's weight, which is critical to improving its efficiency and range. The lightweight nature of the solar car's body and chassis means that less energy is needed to move the car. This, in turn, means that the car can travel further on the same amount of energy, making it more efficient and cost-effective. Additionally, the use of lightweight materials improves the car's handling, making it more responsive and agile on the road. The body of a solar car is also designed to be aerodynamic, which further improves the car's efficiency. By reducing the amount of drag that the car experiences as it moves through the air, less energy is required to maintain its speed. This is important because the amount of energy that can be captured by the solar panels is limited, so any reduction in energy consumption is critical to extending the car's range. The chassis of a solar car is typically designed to be strong and rigid, providing a stable platform for the other components of the car. The chassis must also be lightweight, so advanced materials are used to achieve this. The chassis helps to distribute the weight of the car evenly, improving its handling and stability. In conclusion, the body and chassis of a solar car are essential components that play a critical role in improving the car's efficiency and performance. The use of advanced materials such as carbon fiber helps to reduce the car's weight, improve its handling, and reduce its energy consumption. With continued advancements in technology, the future of solar cars looks promising, and we can expect to see even more innovative designs and materials being used to create more efficient and environmentally friendly vehicles. The wheels and tires of a solar car play a crucial role in the car's performance and efficiency. Unlike conventional cars, where the focus is on improving traction and handling, solar cars are designed to reduce rolling resistance and improve efficiency. Rolling resistance is the force that must be overcome to keep the wheels of a car moving forward, and it can be a significant source of energy loss. To reduce rolling resistance, the wheels and tires of a solar car are specifically designed to be as light as possible. This is achieved through the use of lightweight materials and advanced engineering techniques. The lighter the wheel and tire assembly, the less energy is required to keep them moving, which in turn improves the car's efficiency and range. In addition to being lightweight, the tires of a solar car are also designed to be narrow with low-profile sidewalls. This design helps to reduce the contact area between the tire and the road, which reduces rolling resistance. The tires are also inflated to a high pressure, which further reduces rolling resistance and improves efficiency. The wheels of a solar car are typically made from lightweight materials such as aluminum or carbon fiber. The use of these materials reduces the weight of the wheel assembly, which, as mentioned earlier, improves the car's efficiency. The wheels are also designed to be aerodynamic, with the shape of the spokes and the hub reducing drag as the car moves through the air. Another critical aspect of the wheel and tire design is the use of low-friction bearings. These bearings reduce the amount of energy that is lost due to friction, allowing the wheels to spin more freely and with less resistance. In conclusion, the wheels and tires of a solar car are specifically designed to reduce rolling resistance and improve efficiency. Through the use of lightweight materials, low-profile tires, and high-pressure inflation, solar cars can travel further on the same amount of energy. With continued advancements in materials and engineering, we can expect to see even more efficient and effective wheel and tire designs in the future.